Okay, so we will start by our next practice that is on K-means or clustering in general, but we will do it with K-means. And for this theoretical class, what we will use is a data set about the number of bags that a collection of stores selling only avocados are doing in the US. Okay, so let's see how the data looks like. So first we have a number of bags that they have sold during number of years. So here you have different stores and different months of the year and how many bags they have sold in that month. So here we have 8,000 bags, and they distinguish between small bags, large bags, and extra large bags. And we have many stores, many months, and so on. Okay, so the first thing is to get acquainted with the data, as always. So we will make some summarization. So let's see, this is the number, well, this is the beginning of the table, and then this is number of small bags. So we have minimum, maximum, and median. Then number of large bags, and again minimum, maximum, median, and number of extra large bags, and then the month for which they have sold this amount. But there is something to highlight that are these zeros. So these zeros means probably that they have not recorded this data, because we will see that it is very unlikely that you sell extra large bags in 1 month and you have zero small bags or zero large bags. So this is not really in the whole month. So this is not really faithful data. So we will have to clean those. And then we have months as expected. They are equally, more or less equally distributed. And then we have the covariance matrix that we see one of the variables is dominating the rest. So this is small bags, large and extra large. So the small bags are dominating the rest of the variability. And we can also look at the correlation matrix, and the three number of bags are very highly correlated, but small and large bags are more correlated than small and extra large. Okay, so if we make a plot with all those data, what we see are these very much concentrated histograms. So that means that there are some outliers here that are driving, well, we can see them here too. They're driving the construction of the histograms of the plot, but most of the data is concentrated at the origin. And we see this correlation between a small and large. So we see kind of line, but we also see kind of L, and this L means well, that kind three different trends. So there one trend here, another trend that is the other arm of the L, and then the general trend that is the correlation between the two. Okay, so let's see if we can do K-means on this. So the first thing is to make a plot, and for doing that we will remove the outliers, and then we will see how everything looks like. And because we are more interested in the structure of the months rather than the specific amount of a small, extra large, or large bags, so we will normalize the data to have to be distributed between 0 and 1. Okay, so let's execute this section. So here we have the plot of the remaining data, and this is not the one that has been normalized. You see that the normalization is performed after the plot. So this is after removing the outliers, what data we have. And so there is very small variation in the extra large axis and much more variation in the small and large axis. Okay, good. So then what we will do next is we want to compute K-means, and for computing K-means we need to use a clustering algorithm, or do it. We want to do clustering, and for doing clustering we will use K-means. And we know that K-means is depends on the on the specific runs. So we will repeat for every possible number of clusters. We will go from 1 to 15 clusters. We will do 100 replicates, and then we will plot what is the quantization error. Let me run this section already. So we will plot the quantization error and choose the quantization error that minimizes the error, and we are not doing a too strong overfitting. And we will do that by looking at the plot and then choosing a number that gives a good trade-off between quantization error and complexity of the model. The complexity of the model for K-means is just the number of clusters. Okay, so this is the plot, the quantization error. We see with a single cluster we have a lot of error, and then probably just 2 would be good enough, but probably you want to be more precise. So you choose a number somewhere here. So I have chosen 9 for this video, but it doesn't need to be necessarily a good number. So probably somewhere between 3 or 4 and 6, 7, 8, 9 even would be a good thing. Okay, so let's do it with 9. So now we have we are repeating the clustering with 9, and what we get is the following. So I'm plotting just in the small and large variables in the space defined by small and large, and what we see is that well, one of the clusters, that is this number 7, is the small, or this number of bags is a small, number of large bags is also small. So these are months for which you don't sell so much. These are months that you sell much more small bags than large bags, and well, you have all possibilities. And we see that the clustering has divided the space into kind of homogeneous regions. It is also very interesting that these homogeneous regions, they don't have the same shape. So where you have more data, you have smaller regions, so that you minimize the quantization error in those areas by adding more and more samples. Okay, so this is an interesting plot. And then let's look at this one. This is the count of how many points you have in each one of the clusters. So as expected, these small things are more populated, and the next one is 1. So either so the next most populated cluster is the one in which the number of large bags is a little bit larger. And then, well, you have all kind of distributions. For instance, this one is 4, that is the less populated one. And then we have also plots. So let's let's have this plot here. So this is the plot. The next plot we have is the histogram of each one of the clusters with respect to the month. So here we have, for instance, the most populated one was cluster 7. We see that cluster 7, you sell more, so there are more elements in cluster 7 that are coming from the first 3 months. So in the first 3 months, it seems that you are selling a bit less of avocados, and then the rest of the months you are not selling so few. So selling few means we know that we are selling few because we are selling a small number of small bags and large bags. And yeah, and then you can, for instance, which are the months for which you sell a lot. So for instance, 5 and 9. So 5 and 9. So you sell a lot on the first month, 5 and 9. So it is at the beginning of the year that you are selling more avocados. So you also sell more small bags, but not because you are selling less, but because you are selling more in general. So you are selling more large bags, small bags, but also there are more months for which you are selling not so many. Okay, and maybe you may have noticed that these axes are not equivalent. This goes to 600, the rest it depends. So it may be convenient to plot all of them with the same size so that you get a better idea of what are the relative sizes of the different clusters. So you see that cluster 7 is really the one dominating, and then cluster 5 and cluster 9 that we have also analyzed a little bit more in detail. So they are much smaller than cluster 7, but we see still that pattern that at the beginning of the year you are selling more bags. Okay, so that is all for this presentation, and let's see you next time. And